Hello and welcome back to Tutoring Success, my level 7 pioneers. In this video, I'm going to teach you how to prove the Tan-Chord Theorem. By the end of this video, you should be able to do it by yourself. And should it pops out on your test or your exam, you are going to nail it. So firstly, we are going to state what we are given. So we are given center O and a tangent DCE and a chord that subtends A at the circumference. And what we are required to prove, we are required to prove that angle BCE, which is this one, angle BCE is equals to angle A, right? That's what we are required to prove. So same as each and every proof, we are going to construct. So what are we constructing in this proof? We are going to construct radii OB and OC. So where is OB and OC? This is going to be our OB and this is going to be our OC, right? So after that, we are going to start our proof, guys. So firstly, on our proof, guys, I forgot to state that we must let angle BCE to be equals to x, right? So we can start by analyzing, guys, as we always do. So we are given two radiuses or radii. So we are having OB is going to be equals to OC, right? And what does that mean to us? It simply means that this angle is going to be equals to this angle, right? So angle OCP is going to be equals to the angle of OBC, right? And what else do we know about a radius and a tangent? We know that these two, they must give us what? They must give us 90 degrees, right? So we must put that in writing, guys. So we are going to say OB is equals to OC. Our reasoning is going to be radii, isn't it? And then on our next step, we are going to say angle OCE is going to be equals to 90 degrees. What is our reasoning? You can just say radius is perpendicular to the tangent, right? And then after that, you are going to say in order to get angle OCB, right? In order to get angle OCB, you are going to say angle OCE is actually equals to angle BCE, right, plus angle OCB, isn't it? So basically, I'm saying this angle plus this angle must give us 90 degrees. So we know that OCE is our 90 degrees and our BCE is equals to our x, and then our OCP, that's what we are looking for, right? Our OCP. And then when we are transposing, we are going to be left with angle OCE is basically equals to 90 minus x, right? So we are going to include that on our diagram. So that simply means this angle is going to be 90 degrees minus x. So what does that mean? It simply means that this angle is also 90 minus x. So if there's any question, guys, please don't hesitate to post it on our comment section below. And then after that, you are going to say OCP plus that's my mistake, guys, is actually OCP is going to be equals to OBC, right? And then our reasoning, you are going to say angles opposite equal sides, right? So what I normally say is that base angles of an isosceles triangle are equal, because if you can look at triangle OBC is an isosceles triangle, right? So you are going to say in triangle OBC, we are going to be having angle C plus angle O plus angle B. They are going to give you 180 degrees. And our reasoning, you are going to say sum of angles in a triangle, right? In a triangle. So On our next step, we are simply going to substitute. We know that our angle C is going to be 90 minus x, and our angle O, that's what we are looking for. And our angle B is going to be 90 minus x equals to 180 degrees. So if we can look, guys, 90 plus 90 is going to give us 180 degrees, isn't it? And then when we transpose that 180 degrees, it's going to cancel this one on our other side, right? So there's no need to do that one. And then we have minus x, that's going to be our, that's simply going to be negative x, isn't it? So we are going to be having O minus 2x is equals to 0, right? And then after that, we are looking for O. So O is going to be equals to 2x. So let me try to drag our diagram down. So if you are having any question, guys, please don't hesitate to post it on our comment section. And if this video is valuable to you, put that like button. So let's carry on. So we finally found O, angle O, I mean. So angle O is equals to 2x, and we know that angle O is 2 times angle A, right? So we are going to say angle O is equals to 2 times angle A, and our angle A, I mean our reasoning actually our reasoning, I'm sorry guys, our reasoning is going to be angle at the center is equals to 2 times angle at the circumference, right? And then on our next step, we are simply going to substitute. We are going to be having 2x for angle O, and then we are looking for angle A. Then we are going to divide by 2 both sides since we are solving for A, right? And then our A is going to be equals to x. And after that, you can conclude that angle BCE is actually equals to angle A. And angle A is also equals to x, right? And then your reasoning, you can say proven. So that's how, guys, you collect all the marks when it comes to Tan-Chord theorem. If this video was valuable to you, please don't forget to put that like button and consider subscribing, guys. So I would like to take this opportunity to thank each and every one of you who subscribe to our channel and continuing liking and watching our channel. So in the next lesson, we are going to be tackling probably a practical question. So on to our next lesson.